Hello everyone. Uh, in this lecture, I am going to explain the instruction set of the 8085 microprocessor. Already we have discussed few things related to the instruction set of the 8085 microprocessor, particularly what is instruction, what is opcode, and operand, instruction word size 1 byte, 2 byte, and 3 byte, instruction data formats, addressing modes, 5 different addressing modes: immediate, register addressing, direct addressing, register, indirect addressing, and implicit or implied addressing mode. The symbols that we are going to use while explaining the different instructions. I'll update these symbols, list of symbols time to time. Now to start with the different instruction set of the 8085. Now based on the different operation, arithmetic and logic or data transfer, with different operation that can be performed by the 8085 microprocessor, the entire instruction set is being divided in 5 categories. The first one is data transfer instruction. So in the data transfer instruction, data are transferred from the source to the destination. That is, source can be any of the registers, source can be memory, source can be any other ports. Then different data transfer possible in 8085 are in between the different registers. Memory to the register, from memory to the register, from IO to the accumulator. But there is, remember one thing, that direct memory to memory transfer is not possible. That is, from one memory location to the another memory location, data transfer is not possible in this instruction. And one another important thing, since it is a data transfer instruction, none of the flags will be affected while executing the data transfer instructions. So start with according to the different addressing mode. Out of the 5 different addressing mode, there are 4 different types of data transfer instruction, because there is no implicit or implied data transfer instruction. So among the 5, we can have only 4 addressing modes in data transfer instructions. The first one is immediate data transfer instruction according to the immediate addressing mode. So under this category, immediate data transfer instruction, there are 2 forms of instruction. One is MVIR, one is MVIR data. So MVI, it means move immediately. So MVIR, where R is the destination registers, when it is R, small r, it means A, accumulator A, or B, or C, or D, or E, or H, or L. These 7 different registers, and this data is nothing but an 8-bit data. So whatever be this 8-bit data will be copied or moved or transferred to the specified register. So move immediately, that is why it is the data immediate after the instruction are copied to the specified register. That is why it is called immediate addressing. The data has been given immediate after the instruction, and as a result it's a 2-byte instruction. So the meaning is, the first bracket represents the content of. So since it is a 2-byte instruction, the first byte is of course the opt, and second byte is the 8-bit data. So the byte 2 of the instruction, that is the second byte, is the data. So this first bracket represents the content of the byte 2 of the instruction, that is nothing but your data. 8-bit data will be copied to the specified register R. So the content of the byte 2 of the instructions are copied or moved or transferred to the specified register R. So the number of byte in this instruction is 2, 2-byte instruction. Machine cycle is 2, and the T state, in the first machine cycle there are 4 T states, and the second machine cycle there are 3 T states, total of 7 T states. And addressing mode, of course, the immediate addressing mode. Actually, whenever you see any instruction ended with I, is immediate addressing mode in case of 8085. And initially only I mentioned, since it is data transfer, any of the data transfer instruction, there is no flag affected. So flag affected none. And in the instruction format, this is the output. This byte 1 is the output, and since it is a 2-byte instruction, byte 2 is the 8-bit data. Now in the instruction format, since there are 8 different instructions, MPI A, MPI B, MPI C, MPI D, sorry 7 not 8, MVI A, B, C, D, E, H, L. So this D stands for the destination D, and it follows the truth table of this. If it is register B 000, register C 001, D 010, like that. Okay. So accordingly, define instructions are MVI A comma data. MVI A comma data means the byte 2 of the content of the byte 2 of the instruction, that is the data. 8-bit data will be copied to the A. Similarly, MVI B means content of the byte 2 of the instruction are copied to the B, register B, and so on and so forth. Okay, the output in case of A, it is 1 1 1. So 0 0 1 1 1. So 0 0 1 1 means it is 3, and 1 1 1 0 is E. So the output is 3E. Okay. Similarly for MVI B, for B it is 0 0 0. So it is 0 then E. Sorry 0 6 0 6 and so on and so forth. So these are the A7 different instruction under MVI R comma data. So this is the instruction for 8-bit immediate data transfer. Similarly for the 16-bit immediate data transfer, the instruction is LXI. Here also you see the instruction ended with high, so it is immediate addressing. LXI RP. LXI means load register pair HL. Load register pair immediately. So RP stands for the register pair. So of course the data has to be 16-bit. Since it is, we are using register pair, total of 16-bit. So LXI RP data 16 means this data 16-bit data will be copied to the specified register pair RP. So since it is a pair, there are 3 pairs possible: B, C, D, E, and HL. Now the instruction which are applicable for the register pair are also applicable for stack pointer. So this RP also stands for the stack pointer in this regards. Okay. So suppose it is a BC register pair, we will specify only B, LXI B, not BC. Similarly, if it is DE pair, so LXI D. Similarly, HL pair, we will write LXI H. So along with the LXI, only first register will be indicated. Suppose LXI B only, here we will write only B, that means BC register pair. So if it is a suppose BC register pair, C is the lower byte, B is the higher byte. So the lower byte of this data, which is in the byte 2 of the instruction, will copy it to the C, and higher byte of the data, that is third byte of the instruction, will copy it to the B. So here I am indicating RPL, RPH. So lower byte of the register pair, higher byte of the address register pair. So content of the byte 2 of the instruction are copied to the lower byte of the register pair. Content of the byte 3 of the instructions are copied to the higher byte of the register pair. So the content of the byte 2 and the byte 3 of the instructions are copied or moved or transferred to the specified register pair RP. So of course it is a 3 byte. So first byte is the output for LXI RP, and there are 2 bytes in this data, so total of 3 byte instruction. And machine cycle is 3. In the first machine cycle there are 4 twisted, second machine cycle 3, and third machine cycle 3. So total of 10 twists. Addressing modes, of course, immediate addressing mode, flag is none, and instruction format. The byte 1 is our output, byte 2 is the lower byte of the data, byte 3 is the higher byte of the data. Okay. So in this instruction format, as you see, 00 RP 0001, this is the opcode or instruction format, which is dedicated fixed, and RP stands for the BC, DE, HL, and SP. So it also follows the truth table place. When it is BC, that RP will be 00, DE 01, HL 10, SP 11. So therefore there are different instructions like say LXI B, as I mentioned, is B for BC, D for DE, H for HL. So LXI B means it is indicating BC register pair. So BC register pair will be loaded with the data 16, the 16-bit data. Data 16 means it is a 16-bit data. So the lower byte of this data is copied to lower byte address, lower byte register C, and the higher byte of this data will be copied to the higher byte of the register B. So lower byte of the data is nothing but the byte 2 of the instruction, higher byte of the data is nothing but the byte 3 of the instruction. So the content of the byte 2 of the instruction is copied to C, content of the byte 3 of the instruction is copied to register B. And now since it is BC, so here it will be 0 0. So together it becomes 0 1 opcode. Similarly LXID, LXIH, LXISP. So this is your immediate data transfer instruction. This two only, MVI R, data, LXI RP, data 16. In case of MVI R, data, there are 7 instructions, and in case of LXI RP, data 16, there are 4 instructions. Now, the second category of the data transfer instruction is based on the direct data transfer. The direct addressing mode is the direct data transfer instruction. So in this direct data transfer instructions, data is, suppose the data is in your memory and is being copied to the different registers. So the address of that memory where data is present is directly given along with the instruction. That is why it is called direct data transfer instructions. So in this instruction, data is transferred to and from the memory, and the address of the memory location is given in the instruction itself. There are two forms of these instructions, one for the 8-bit data, another for the 16-bit data. So in the first form of such instruction, that is for the 8-bit, data transfer takes place between accumulator and the memories. Only the accumulator and the memory location. So the instruction is LDA address. So whenever we write this DDR address, it means the address of the memory location. The meaning of this LDA is load accumulator directly. So accumulator will be loaded with the data whose address is specified in the instruction itself. That means data is somewhere in the memory. The memory where data is present, the address of that memory is given directly along with the instruction, and data from that memory location will be copied to the accumulator. So the accumulator is transferred with the data. So here I am using double bracket. So the first bracket byte 3 and the byte 2. Okay, so byte 3 and the byte 2 of the instruction contains this address, and then outer bracket means the content of that memory location. So the meaning of this is the content of the memory location whose address is specified in the byte 2 and the byte 3 of the instructions are copied to the accumulator. So therefore it is a 3-byte instruction. So therefore this LDA address, there is an opcode for the LDA along with the 16-bit address. So therefore the instruction is of 3 byte. So number of byte here is 3 byte. Machine cycle here is 4. Machine cycle 4. In the first machine cycle there are 4 states, and second, third, and fourth machine cycle there are 3 states. So total of 13 states. Addressing modes, of course, the addressing direct addressing modes right now. Now this is only one instruction, LD address. There is no other instruction. So the instruction format here. So the instruction format, the opcode is 0 0 1 1 1 0 1 0. So it is 3A. The opcode is 3. Another instruction of this type is just opposite to the previous one, that is STA address. STA address, that is store accumulator. Store the content of the accumulator into the specified address directly. So this is also 3-byte instruction. The opcode is for STA and the address 16-bit. So this is the byte 2 and the byte 3 of the instruction. So byte 3 and the byte 2 of the instruction represents the memory address, and the content of the memory address means the outer bracket. So the content of the accumulator is copied to the memory address, memory location whose address is specified by the byte 2 and the byte 3 of the instruction. Okay, this is also 3 byte instruction, machine cycle 3, 4, just like the previous one. Here also twisted 13, addressing mode direct, flag affected none, and this is their instruction format. So 0011, 0010, which is 32 is the output. So these two are the first form of the instruction of the direct data transfer, that is for the 8 bit, from the accumulator to from the memory location to the accumulator, and from the accumulator to the memory location. And the second form of the instruction, it is for the 16-bit data transfer. So 16-bit data transfer takes place between H cell register pair, point to be noted here, like H cell only H cell register pair. So that is the specialty of the H cell register pair, one of the specialty of the H cell register pair, not the other pair, only the H cell register pair. So there are two instructions again, LHLD address. So LHLD means load HL register pair directly. Now here is one thing, then LHLD, that is the load HL register pair. So HL together becomes 16-bit. From where? From the memory, and you are specifying only one memory address here. So one memory address can contain only 8 bit of data, but we need 16-bit data because we are considering H cell pair. So what happened in this case, the address that you are specifying here, the memory location, the data content of that memory location will be copied to the lower byte of the address. And how the H will be filled up? H will be filled up from the data whose address from the memory location whose address is one more than this. That is, you have to store your data into consecutive memory location, not here and there. So as you see here, byte 3 and byte 2, which represents this address, and content of that address memory location is copied to L, and that the byte 2 and the byte 3, that means this memory address plus 1, that means one more than that of this address. The content of that address is copied to H. So we can write it like the content of the memory location whose address is specified by the byte 2 and the byte 3 of the instructions are copied to the register L, and the content of the memory location whose address is one more than that of the specified in byte 2 and the byte 3 of the instructions are copied to the register H. So it is also a 3 byte instruction. So here the point to be noted here is you have to store your data in the memory in two consecutive memory location, and the first address is specified along with the instruction. Second is automatically it is understood. So number of byte is 3, but here in the machine cycle is 5. So 5, the first machine cycle 4, then second, third, fourth, fifth machine cycle will have the 3, 3, 3. So together there is 16 T states. Addressing mode is direct addressing mode, flag is none, and your instruction format here, as you see, 00101010, that is 2A. Output is 2A, and the second byte is the lower byte of the address, third byte is the lower byte of the higher byte of the address. Like LHLD, it is the load HL register pair. Similarly, HHLD, store HL register pair directly. So it's the same as that of the previous one only, but just opposite. So from L, the data will be copied to the memory location whose address is given here, and from H, data will be copied to the memory location whose address is one more than this address. So the content of the register L are copied to the memory location whose address is specified in the byte 2 and the byte 3 of the instruction, and the content of the register H are copied to the memory location whose address is one more than that of the address specified in byte 2 and the byte 3 of the instructions. Here also the number of byte is 3, machine cycle 5, twisted 16, and direct addressing mode instructions, and flag none, and your instruction format. Instruction format is output is 22. Okay, so the third category of the data transfer instruction is register data transfer instruction, that is based on the register addressing mode, or also called register direct addressing mode. Now, one thing to be noted here is, in this case, this is the largest group of the data transfer instructions. Okay, largest group of the data transfer instructions. So here you will have total of 49 instructions. Okay, in this group, under this group, what happened? Data will be transferred from one register to the another registers. So there are 8-bit, 6 general purpose 8-bit register along with one 8-bit special purpose register, that is accumulator. So together a total of 7 registers, 8-bit. So from one to another, say A to B, B to A to C, C to A, like that. So the common form of the instruction is move R1, R2. So where these R1, R2 are nothing but any one of the register A, B, C, D, E, H, L. Okay. Now remember one thing, this first one, that R1 is the destination and R2 is the source. So the shortcut meaning is the move registers. So move the content of the register R2 to the register R1. So R1 is coming from R2. The content of the register R2 are copied or moved or transferred to the specified register R1. So it's just an 1 byte instruction, only opcode is sufficient. Machine cycle 1 is that 4. Addressing mode, of course, register direct or register addressing mode, flag none. And instruction format, as you see here, it is only 1 byte, so there is only 1 byte instruction format. This is opcode only 0, 1. D, D, D stands for the destination, S, S, S stands for the source, and it follows this truth table. V or S follows the same truth table. So accordingly, there are 49 instructions. Suppose the instruction is move A, A. There is no meaning of this A, A, but still this instruction is also there. Similarly, move B, B, move C, C, move D, D does not have any meaning. I mean, make any changes, because it is C to C, D to D, A to A, B to B, like that. But still that instruction is also there. Otherwise, move A, B, move A, C, move B, A, like that. Okay. So here I am forming this table. This is the source, this is SSS, and this is the destination. So the instruction is move. So move B, B. This is your destination, this is your source. Okay, this is your destination and this is your source. So move B, this B, this B. So if it is B, this DDD or SSS is 0. So if it is 0, 0, 0, again 0, 0, 0, so the output will be 0, 1, 0, 0, that is 4. 0, 0, 0, 0, that is 0, so output is 40 hex. Similarly, move B, C. So that means from C to B, that I will copy. The content of the register C will copy to the register B. So B means 0, 0, 0, 0, 0, 0, C means 0, 0, 1. So it will be 41. Okay, so and so forth. For example, move A, L. Move A, L. That means content of the register L will be copied to the register A. So A means here 1, 1, 1. So it is 1, 1, 1, 1, 1, 1. Sorry. A means 1, 1, 1, 1, 1, 1, and L means L is your 101. So it is 101. So 0, 1, 1, that is 7. 0, 1, 1, this is your 7. Then 1, 1, 0, 1, that is D. So therefore the output is 7D. So likewise, you see there are 14 instructions: 1, 2, 3, 4, 5, 6, 7, and 7. Total of 49 instructions. So this is the largest number of instructions, but you need to remember only move R1, R2, and you need to understand that this R1, R2 can be any of the register A, B, C, D, E, H, I. Okay. Now in the next category of this instruction is XCHG. That's all only. XCHG. So XCHG is X meaning is exchange. Exchange. So what to exchange? Whom to exchange? Exchange the H cell with DE only. Remember, exchange the data in between H cell and DE register pair, not the others, only H cell and DE. That means whatever be the content of E, that will be copied to L, and whatever be the content of E will copy it to L, and whatever be the content of L will copy it to E, then D to H, H to D. Just exchanging the data in between E and L and in between D and H. So the meaning is, say H okay. Just copy it L. H is with D, and here L is with E. Okay. So the meaning how we will write is, the content of the register H and L are exchanged with the content of D and E respectively. Okay. So here also the number of byte 1, this is also 1 byte instruction. Machine cycle here is 1, tested here is 4, addressing mode register direct, flag is none, and in the instruction format it is 1 1 0, then 1 0 1 1. So therefore the output here is, this is only one instruction, so output here is E B. Okay. So these are the two instructions only under the direct register direct data transfer. Okay. Next is your register indirect data transfer instruction. So in the register indirect data transfer instruction, there are particularly two form of instructions. One is for 8-bit, one is for 16-bit, and in case of 8-bit there are 3 instructions, and in case of 16-bit there are 2 instructions. So the first instruction and the first form, in the first form of instruction, that is your move r comma m. Now here is a significant point. So move r comma m, whenever you see m, m means the memory location, but whose address is currently in HL register pair. So therefore m can be considered as a virtual register, and whatever be the operations you can do with the registers B, C, D, E, H, L, all the instructions, all the operation you can perform it m also. So m can be considered as a register like B, C, D, E, H, L. You can consider as a register. Now thing is that, so this m is a virtual register, and remember one thing, it can be virtual register only when the address of that memory location is presently in HL register pair only. Okay, so m is nothing but your memory location, any memory location, particularly RAM location, whose address is currently or presently in HL register pair only. Okay, so therefore it is indirectly representing, the source is indirectly representing a memory location. That is why it is register indirect. Okay, so the immediate meaning is move from memory. Technically what it is, data will be copied to the specified register R from the memory location M, but whose address is currently in HL register pair. So the meaning of this is the content of the memory location whose address is currently in HL register pair. So therefore I have used two brackets. Content of this inner bracket means content of HL. What is the content of HL? A memory address. Then outer bracket means content of that memory location whose address is in HL register pair are copied to R. So whenever any memory location is, address of the memory location is in HL register pair, then that memory location is considered as M. Okay, so you can write like the content of the memory location whose address is stored or present in HL register pair are copied to specified register R. and R is nothing but any of the register A, B, C, D, E, H, L. Okay. Okay, so this is a 1 byte instruction. This is a 1 byte instruction, and machine cycle here is 2. In the first machine cycle there are 4 T states, and the second is 3, so total of 7 T states. Addressing mode is register indirect addressing mode. Flag of course none. And in the instruction format it is 0 1 D D D D D D for destination, then 1 1 0 0 1 D D D 1 1 0. So there will be then 7 instructions under this category. So the different instructions are move A, M, then move B, C, M, D, M, E, M, H, M, L, M. So here it will be A is copied from the memory location whose address is specified in HL register pair. Similarly, now the opcode, so move A, M. A is the destination, so here A means 1 1 1, so it is 0 1 1, then 1 1 1 0. So 0 1 1 is 7, 1 1 1 0 is E, so 7 7 E. Okay, similarly it will be 46, then C is 0 0 0 0 0 1 0 0 1, so 4E, then 5 6, because D is 0 1 0, so 5 6, then 5E, then 6 6, then 6 E, because H is, what is H? H is 1 0 0 1 0 0. So H is your 1 0. So that is 4. Sorry. 1 0 0. So 6. So it's okay. Okay. So these are the different instructions for the move B comma M comma R comma M. Similarly, just the opposite one. Move M comma R, just the opposite one. So it means again M is same, the memory location whose address is in HL register pair. So from our R it will copy to the memory location whose address is in HL register pair. So move to memory. Just the opposite one. So it is from that specified R, the data will be copied to the memory location whose address is in HL register pair. So I will write the content of the specified register R, the content of the specified register pair R are copied to the memory location whose address is stored in HL register pair. So here also number of byte 1, machine cycle 2, then T state 7, then addressing mode also register indirect, flag affected none, and the instruction format is 0 1 1 0 S for source. Okay, and the different instructions are move M comma A, move M comma B, move M comma C, move M comma D, move M comma E, move M comma H, then move M comma L. Okay, so these are the different instructions. Now the output for A, it is 1 1 1, so it is 77. So 1 1 1 0 1 1 1 7, then 0 1 1 1 7. Then B is 0 0 0, so 7 0. Then C is 0 0 1, so 7 1. D is 0 1 0, that means 72. Similarly 73, 74 and 75. Okay. Now the third category of this instruction is immediate. M, comma, data. So you see here M again, same the memory location whose address is in HL register, but it is immediate. That immediate data, 8-bit data, will be copied to the memory location whose address is in HL register. So move to memory, meaning is move to memory immediately. Okay. Now this is a special kind of instructions where because of this M, the addressing mode is register indirect, as well as since it is immediate, so it is also immediate addressing mode. So it follows two addressing modes, register indirect as well as immediate. So as you see here, so instead of this, it will be H L. That means the byte 2 of the instruction, which is nothing but this 8-bit data, will be copied to the memory location whose address is in HL register pair. Okay. So the meaning, how will you write? The content of the byte 2 of the instructions are copied or moved to the memory location whose address is in HL register. Yeah. So here number of byte is 2. First byte is for the output, second byte is for the data. Number of machine cycle is your 3 here, and the T state is therefore 10. Addressing mode here, addressing mode is here two types of addressing mode. It follows. One is register indirect as well as immediate addressing mode. Finger factor, of course, known. Instruction format. And in the instruction format, it is 1 1 0. So the output here is 36. Output here is 36. Now in the fourth and fifth, these two are the instruction. So in the fourth category, it is for a 16-bit. The instruction is LDAX RP. In this instruction, LDX means load accumulator. Load accumulator, where from it will load from the memory location whose address is in specified register pair RP. Okay. The meaning is load accumulator. Load accumulator indirectly. Why it is indirectly? Because it is also specifying the memory location, but indirectly. Indirectly means the address is in RP. Now here there are a few things to be noted down. This instruction is something like LDA. Already discussed. So LDA, for example, suppose 2050. So what is the meaning of this? For example, 2050. What is the meaning of this instruction? The meaning of this instruction is load the accumulator directly from the memory location 2050. That means some data is there in your 2050 memory location. That data will be copied directly to the accumulator. Okay. Now suppose this LDAX RP, instead of RP, suppose I am typing B. Okay. So that means it is your BC register pair, and in B and C, suppose 2050 address is stored. That means this 50 is stored in C, 20 is stored in B, because it is lower byte 50, higher byte 20. So if this 2050 is stored in BC, then you are executing LDXB is exactly same as that of LDA 2050. Okay. Also move A comma M. So what is M? M is the memory location whose address is in HL register. So suppose in your HL, this 2050 is there. That means 50 is in HL, 20 is in H. That means HL is having the address 2050. Then you are doing MVA A comma M. That means move the content of the memory location 2050, which is already there in HL register pair, are copied to the accumulator. So in that case, if suppose your BC or similarly DE also, LDX DE also, if there is the same address as in DE register pair, then all these three instructions will have the same meaning, same thing. LDA 2050, suppose your data is in 2050. So you can have this LDA 2050. You can copy that 2050 to BC or DE register pair, then LDAXB or LDAXD will have the same meaning, same operation. Then you can copy that address in HL register pair. Then if you write move A, M is also same. Okay, try to understand that fact. Now, since HL is a dedicated register pair, so here in these particular instructions, although I already mentioned this RP means BC, DE, HL along with SP also their stack pointer, but particularly for this instruction LDAX, this RP means RP stands for only BC and DE, not for HL, not for SP stack pointer. Why not for HL? Because HL is a dedicated pair which is representing M. If the memory is in HL, that memory is pointing as a virtual register M. So this LDX RP here, this RP is only BC and DE. Okay, so how will we write? A coming from RP directly, double bracket, because within the RP actually it is RPH, RPL, lower byte and a higher byte. So combining this lower byte, higher byte, memory address is there, and the content of that memory address is copied to accumulator. So how will you write the content of the memory location? Whose address is in the register pair in the specified RP. The content of the memory location whose address is in the specified register pair RP are copied or moved or moved or transferred to the accumulator. Okay. So here number of byte is here number of byte is here 1 byte instruction. Machine cycle here is your 2, this state here is your 7, addressing mode here is register indirect, register indirect addressing mode, flag affected none, in the instruction format. This is the byte 1 only, there is no byte 2. This is opcode, so instead 00 RP 1010. So the different instructions. different instructions here. LDAX, B for BC. So A will be loaded from similarly LDAX D. So this and for BC, as you know, this is 0 0, so 0 A is the output, and for DE it is 1 0, that means 2A 1 0, sorry 0 1, not 1 0, 0 1 0 1, so it is 1A. These two are the instruction only. Okay, next is just the opposite of this. That is here 5. It is STAX. So it is something like STA. As I explained here, all the opposite instructions are also like STA, like move M, A, like that. So it will be store accumulator, store accumulator indirectly. So the content of the accumulator are copied to the memory location whose address is in the specified register RP. Okay. Here also the number of byte is 1, number of machine cycle 2, T-state 7, and decimal register indirect, flag none instruction format. Here it is 00 RP 0010. So here it is STAX B, STAX D, so B for 00, that means it is 02, and 01, so it is 1 2. Okay, that's all about the data transfer instructions. Okay, so the different data transfer instructions: immediate data transfer instruction, MVIR comma data, then LXIRP comma data 16, that is 16-bit data. Then in the direct data transfer, LDA address, STA address, LDA is store load accumulator, STA is store accumulator. Then LHLD address, load HL register pair directly, and SSLD address, store HL pair is HL directly. Then register data transfer, move R1, R2, XCSG. Then register indirect, move R, M, move M, NVIM, data. Then LDAXRP, SDAXRP. So these are the data transfer instruction. There is no other data transfer instructions. So in my next lecture, I'll go through the arithmetic instructions, then followed by logical. Thank you very much.